We want to know and use the condition for two lines to be parallel. Parallel lines. Two or more lines are said to be parallel if they move in one direction. When these lines are extended, they do not meet. So we see in the diagram below that when these two lines are extended, they never meet because they move in one same direction. In mathematics, we use arrows to indicate that those two lines are parallel. Are the two lines below parallel? For this scenario, we see that when these two lines are extended, they eventually meet at a point. So for this example, the two lines are not parallel. Now we have these two lines here having gradients M1 and M2. Parallel lines have the same degree of inclination to the horizontal, that is, parallel lines have the same gradients. We are saying that if we draw a horizontal to these two straight lines, the angle made with the horizontal will be the same. For instance, if this one is 45 degrees, this will also be 45 degrees. And so finding the gradient M1 equals tan 45, we are going to get 1. Gradient M2 equals tan 45. We are going to get the answer to be equal to 1. Thus the gradient of parallel lines is the same. M1 equals M2. Let's have the first question. Point C and point D are points in the XY plane. Find the equation of the line passing through T and parallel to CD. So the equation says that we have a first line. We have a first line CD. And then we have a second line which passes through T and is parallel to CD. So I draw it as such. Two lines are parallel. This second line passes through the point T. 6,2. We are finding the equation of this line that passes through T. Okay. Finding the equation of the line that passes through T, we make use of y equals ms plus c. But we see the m, the gradient of the line passing through T, is not known. So what do? We know that gradient of CD equals gradient of line passing through T, M1 equals M2. So what we do is we first find a gradient of CD. Gradient of CD equals change in y let the point C be S1, Y1, the point D be S2, Y2. So change in y minus 1 minus 3 divide 4 minus 10. And that gives minus 4 divide 6. Gradient of CD is 2 out of 3. It tells us that the gradient M2 is same as the gradient of line CD. So now equation of the line passing through T, y equals ms plus c. The point T lies on the very line we are finding, so we can substitute the coordinate of T into it. The point T lies on this very line we are finding. So it means Y is 2. We have found the gradient to be 2 out of 3. S is 6. And that gives the value of C is -2. So this equation now becomes Y equals ms plus C. This is the equation of the line passing through T. The next question. A straight line L1 having the equation 3s plus 2y equals 10 is parallel to the line L2. The two lines are parallel. The line L2 passes through the point A and B. Find the value of P. Okay. Gradient of L1 should be same as gradient of L2 because the two lines are parallel. So this is the information we want to use to solve the question. But then, what's the gradient of L1? Equation of L1 can be rewritten in the general form y equals ms plus c. So we see clearly what the gradient is. Thus, we want to make y the subject of this equation. Divide each term by 2. Tells us that gradient of L1 is -3 out of 2. Then how do we find the gradient of L2? Gradient of L2, we do change in y, y2 minus y1, divide s2 minus s1. And that gives, making use of the condition for lines to be parallel, that the two gradients are the same, we write -3 divide 2 equals the other one 3 divide 5 minus p. When we cross multiply, what do we get? We get 6 equals -15 plus 3p, which in turn gives 21 equals 3p, dividing both sides by 3, the value of p to be equal to 7. So it tells us that the coordinate of the point A is 7, -1.